Okay, here's some notes on properties of logarithms. We basically have three properties, sometimes called laws of logarithms, that we use. And I kind of notated them here and gave you an example so you can see what's going on. The first one, well, first of all, we want to make sure that m is greater than 0 and n is greater than 0. Then if that's the case, we know that the log to the base b of m times n equals the log to the base b of n plus the log to the base b of n. And that's what we call the product rule. Now remember, logarithms are exponents. So when you multiply, like x to the second times x to the third, what do you do with the exponents? You add them. That would be x to the fifth, x to the 2 plus 3. So these are just following the same idea because logarithms are exponents. So when we multiply, we add the logarithms. And this is basically, sometimes we say this is the log of a product is the sum of the logs. One log, product, two logs, sum. So the log of a product is the sum of the logs. Here's an example. The log of this product, 8 times x, is the sum of the logs, the log of 8 plus the log of x, both to the base 2, that is. All right? So the log to the base 2 of 8 times x is the same thing as the log to the base 2 of 8 plus the log of base 2, the log to the base 2 of x. So the log of a product is the sum of the logs. And again, that comes from the fact that logarithms are exponents. Now we can simplify this a little bit more. 2 raised to what power is 8? Remember, this is the exponent that when I raise 2 to it, I get 8. So 2 to the third is 8, so we get to say 3 plus the log to base 2 of x. So we can simplify that even more. All right? Our second property, our second law, logarithms. The log of a quotient, the log of m divided by n, is equal to the difference of the logs. The log to the base b of m minus the log to the base b of n. Again, the log to the base b of m divided by n is the log to the base b of m minus the log to the base b of n. And this is what we call the quotient rule. Remember, quotient means divide. And remember when you were dividing exponents, x to the sixth over x to the second, what do? We subtract the exponents. So 6 minus 2 is 4, that'd be x to the fourth. So the same thing we do here. We subtract the exponents, we subtract the logs. So the log of a quotient is the difference of the logs. The log of a quotient, one log, is the difference of the logs, two logs. Here's an example. This again is called the quotient rule. The log to the base 3 of x over 9 can be also written as the log to the base 3 of x minus the log to the base 3 of 9. Okay, so that's our quotient rule. Now, we could also always simplify this because this is an exponent that when I raise 3 to it, I get 9. And 3 raised to what power is 9? 2. So you could actually simplify that to be 2, and that would be the log to the base 3 of x minus 2. So you could simplify that even a little bit more. Right. And the third one, like I said, we only have 3. And this is the log to the base b of m to p some power, m to a power, equals the power times the log to the base b of m. And this is called the power rule. And the log of a number to a power, the log of a number to a power is the power times the log of that number. So we can just put that exponent in front. And that's going to come in very handy, believe it or not. That's going to come in very handy. You're going to use that a lot. Here's an example. Log to the base b of x to the fifth is the same thing as 5 times log to the base b of x. In other words, you can just put the exponent in front. All right. Now, one thing we haven't mentioned, and which is kind of important, if you see something like log and you don't see a base written down here of x, then this is understood to be log to the base 10 of x, because we used a log to the base 10 for a lot of computations before we had calculators. We used logarithms to make complicated calculations less complex. So we used base 10 because that's our number system is base 10. So we call these common logs. And if you look at your calculator, you'll see an log button, and then you see an ln button. And if you see ln of x, all this is an abbreviation for log to the base e of x, because we use this e base a lot also. It's called a natural logarithm. So this is common logs, base 10, and natural logs, base e. So kind of remember that. So when you see those, you don't say where's the base. If you see this, the base is 10. If you see this, the base is e. So look these over, make sure you understand all these three properties or laws of logarithms, they're sometimes called, because they're very important. We're going to apply them when we expand and condense logarithms, and we're going to do that next.